Hello, this is Jan, developer of the free software Simple Forest. In this tutorial, I would like to show you um, a supervised machine learning technique. Here we see a tree scanned under leaf-on conditions. It's a tropical tree. This is our input scenery, and as we want to deleaf, we might want to go focus on the upper part and ignore the stem, the lower part. So this is what we do with cut cloud above the DTM. So the input, the upper part is used as input for the BeltonEtAl denoising script. I will provide you with a citation for BeltonEtAl paper. You can read how it functions. It will produce 10 clusters. It requires zero training. It's a Gaussian mixture model clustering technique, and you have to manually classify each cluster if it's a noise cluster for you or a good cluster. So let's have a look at the output. I already prepared, as you can see. If you bring 4 of those viewers by clicking this button here and then sync all of those 4 viewers that they share a common camera, then you can easily do the next task. So what you will do is to bring up a single cloud on this screen, and then you decide if it's a leaf cluster, you will put to the first column. If it's a wood cluster, you place to the second column. If it contains points of both wood and leaf, you should classify it as undecided. So this is obviously in majority leaves. So I put to the first column. This is in majority wood. This is contains to my eyes both. So for now I place it here. This is wood again, so I placed it here. This is wood again, the stem. Undecided because it contains both. And leaf, leaf, and again undecided. So now you need to make a screenshot maybe. I cannot show you a second window in because I'm recording just the Compute Tree platform. So make a screenshot out of this. So you have your manually classification viewable, and then you can transfer this manual classification here. So the first was a noise and a wood cluster, then you didn't decide, and so on. So when you do it, you have tagged with a label each of these 10 clusters. Then the algorithm iterates over each point, gets his 199 closest nearest neighbors. In this case, it's a lot of points, but I want to be robust and search quite large group. And if the number of wood points or good points is larger within those 199 closest neighbors, is larger than the number contained of leaf points, it will be classified as wood. If there are more leaf points than wood, then it will be classified as noise. So I already run it, and we can see the output is here. It's already really decent. What I always still recommend to do is statistical outlier filtering. Oops. So I'm sorry. This was classification, the manual classification step with K and N clustering. And after statistical outlier filtering, all of those points are removed. Oops, I wanted to show you the parameters quickly. You need to play around with them. And then what we want to try to do is to connect this isolated wood clusters to the main structure of the tree. So what we need to do is we need to get our filtered group, which you see here on the screen. And as a second input result, we need to get the input cloud, which was the upper cloud and not the buttress stem of the, yeah. So this is how you need to select the input, and then it will run Dijkstra over the input cloud and follow the Dijkstra path to the root out of these clusters. So when we look at the result, we can see here we have generated this path with our algorithm, but it's just a few points. And so what we want to do next is to buffer around each point which you see on the screen, to include also its closest neighbors, which are 6 centimeter close. And then we redo it again 6 centimeters close. So to show you, we buffered a bit again, so we get more points, and hopefully it's enough to fit cylinders. So still next is we want to one time do an Euclidean clustering. So what we have removed is those guys, because they are unconnected and not good enough. One more time, statistical outlier filtering, it doesn't hurt. And then we finally merge again with the lower cloud. So this is our merged cloud. And this is it until here. So what I still do is I cut the cloud above the DTM, but really focus this time on the really buttress part before I export. And why do I do it? This is modeled with a QSM, and this will be modeled with a meshing algorithm, because we cannot really fit cylinders inside. And then I export this cloud, the upper cloud, and also the merged cloud of those two. You will find the script available as usual on my GitLab. I will provide you with a link in the video description. So for now, I say thanks for listening. I hope you find this tutorial helpful, and have a good day.